This video is presented to you by www.testprepadda.com. Dear students, in the previous session of kinematics, I started the discussion of motion of particle under gravity. There I talked about free fall. I talked about motion of particle when it is thrown up from the surface of the earth. In this session, I will discuss few questions. These questions will help you in understanding the concepts which we discussed in the previous session. Now here it is first question. The question says, a ball is projected vertically upward with a speed of 50 meter per second. Find number 1, maximum height. Number 2, time to reach maximum height. Number 3, speed at half the maximum height. And for the question it is given, take G as 10 meter per second square. Now in this question, the initial speed with which the ball is projected up is given as 50 meter per second. Now let us say the maximum height as h, and at this maximum height the velocity will become 0. I can use v is equal to u minus gt here. V is 0, u is given as 50 minus 10t. So this way t comes as 5 seconds. Now to get the maximum height, I can use v square is equal to u square minus 2gh. So this way the value of h comes as u is 50, so it becomes 50 square upon 2 into 10, and that is why it comes as 125 meter. Second, we have to find velocity at half the maximum height. So I'll use v square is equal to u square minus 2g. H now will be h by 2, half of the maximum. Here I'll write 50 square minus 2 into 10 into 125 by 2. And finally it comes as 2500 minus 1250, and 1250 is the final. V square is equal to 1250. Now if you take the root here, velocity will come as plus minus 35.35 meter per second. 35.35 meter per second. Two roots for the velocity. Two roots indicate that velocity v while going up and coming down. Got the idea? So important conclusion here, the motion of the object while going up can be represented with equations like v is equal to u minus gt, number 1. Number 2, h is equal to ut minus half gt square. Number 3, V square is equal to U square minus 2GH. So when the particle is going up, when the object is going up under gravity, since the G is taken as positive in the downward direction, in the upward it will become minus G. So equation will become V is equal to U minus GT, H is equal to UT minus half GT square, and third one V square is equal to U square minus 2GH. Okay, now I'll take another question here. Here the question says, a balloon carrying a stone was going up with a uniform velocity of 4 meters per second. When the balloon was at height 40 meters, the stone was dropped. Find the height of balloon when the stone hits the ground. Here the G is given as 10 meters per second square. Now to solve this question, I will discuss two methods here. First, when the stone was dropped from balloon, stone was going up. The stone was going up. With what speed? 4 meters per second. And from earth, the height was 40 meters. It was going up. So first it will reach to certain height where its velocity will become 0, and from that height it will come like this, free fall. Okay, so first I will get the time to cover this height. So I'll write V is equal to U minus GT. This way T comes as V is 0, U is 4, so 4 by 10 means 0.4 seconds. Okay, now this H height can be found as U square upon 2G. And if I substitute U as 4, so 16 square by 20, and the value comes as 0.8. Okay, so this height will be actually 40.8 meter. So what will be the time to reach ground? T will be equal to root 2h by g. And if I substitute h as 40.8, then it will be 2 into 40.8 upon 10, and the value comes as 2.856 seconds. So what is the total time taken by the particle to reach the ground? Total time taken by the stone to reach the ground? That time T will be 2.856 plus this 0.4. So it is 3.256. Now in the question it is given that balloon is moving up with a uniform velocity 4 meters per second. So the H1 height, because from here we can get that H1 height covered by the balloon in this time 3.256 seconds. H1 height will be 3.256 into 4, and that value comes as 13 meter. Okay, and this height is already given. Balloon at that point when stone was dropped, the balloon was at height 40 meter. So what will be the total height? Total height will be equal to 13 plus 40, and the value comes as 53 meter. Okay. Now I will talk about another method of solving this question. Consider vertical up as plus y and let object reaches the ground in a t time. Then displacement covered will be how much? The displacement covered S will be minus 40 meter. Okay, now use simply S is equal to UT plus half AT square. S as minus 40, U as 4, T we have to find here, plus half. A I will write as minus 10, T I have to find here. So the equation becomes quadratic equation 5t square minus 4t minus 40 is equal to 0. Okay. Now if you solve this, you will get two roots. You will get two roots. One is negative. One is negative. The positive root comes as 3.2567 seconds. Okay, so the stone reaches the ground in this time. If the stone reaches the ground in this time, then how much height the balloon will cover in this time? Just multiply 4, 13 meter. So total height will become 13 plus 40, and that comes as 53 meter. So the two methods of solving the same question. Okay, thank you. This video is presented to you by www.testprepadda.com. TestPrepAdda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.